Hello, this is Nate Vid ET2. Uh, I'm going to go over a basic understanding of electrical electronics. Uh, just to give you a little in-depth in my background, I had computer maintenance school which had electronics. I then went into the U.S. Navy and studied electronics technician, basic electrical and electronics in Orlando. Finished that schooling up in Great Lakes, Illinois, at for advanced electronics and electrical, where we went into radars communication, digital logic, and normal communication. Uh, and after that, I went to my C schools in San Diego, which was the Ames Mark 12 IFF, Identification Friend or Foe, and AN Yuck 62, which is a SNAP system, which kept track of the supply on board and work orders. It also had the availability to do personnel and their qualifications. Here's the basic element, basic atom, and I'm going to go real general, real basic for this. The thing to remember is the outer shell of eight. If there is eight, seven or eight, it's going to be an insulator. Uh, 6 to 3 is semiconductors most of the time. It can be other things, but most of the likely it's going to be semiconductor. Uh, the main two that we used, and I've got to look further into this, was germanium and silicone. But yeah, we'll go more in depth in that, and when we get there, I'll clarify that. The one or two is very good conductors, and that's what is used for conductors. Here you have the electron flow shown. It flows out the negative terminal of the battery or power source to the positive. That is electron flow. There was an old theory of hole flow, HOLE, and that was from positive to negative. I don't think it's used anymore, but I was just giving you a little side information there. This here is inside of a battery. So you can kind of understand what the batteries are. They are not all like this anymore, but some of them still do it. They have the lead acid there on the left. Those are lead partitions there. And the liquid is usually sulfuric acid. If you have to refill those batteries, use all safety equipment, the goggles, the gloves, the face shield, and the apron. You can use sulfuric acid or distilled water. Also, it depends on what acid they use, but clarify what they use before you put it in there. The other one on the right used to be alkaline style batteries, which are still used. It could also be the same makeup for a lithium battery and those rechargeables. Here's a simple series circuit. Don't pay attention to the current flow. It's someone drew it wrong. But yeah, it flows from the negative down through, and you see it has 3 resistors. And that short circuit's going to help me explain a little more in detail because the electrons are going to flow through whatever is the easiest for them to flow, just like a plumbing water. If you have a reducer and a bypass, it's going to take the bypass to go through instead of the reducer because there's not as much force to do it. And the way to look at it is you have a voltage, which is going to be your pressure, how much force you're putting into it. The current would actually be the flow, how it's flowing through. and resistance would be a restriction to those. So you have the current flowing through. It'll flow through here. These, you'll drop voltage here because it's being pressured in through, and so that's that. Now we go to a. This is a series parallel. Actually, it's a little ahead of what I want to cover, but it shows that you have R1, R2, and R3. You can take the R2 and R3 through the inverse formula, which is 1 over R EQ equals 1 over R2 plus 1 over R3. And you do that here for 20 and 30, it'll be 12 ohms. So 12 ohms plus 38 equals 50 ohms. So this circuit is a 50 ohm R resistance total for the whole circuit. The voltage, the current, okay, so you're going to take, to figure out the current, you're going to take the voltage over the resistance, and that equals current. So you divide 25 by 50, and that gives you 0.5 amps. It could also be written as 500 milliamps, but 0.5 amps is okay. Now here's the formula I just used off the top of my head. You have the voltage on top, current, and resistance down here. And this is another way of drawing it. I use this right here because it reminds me of a pi, and that helps me with the power formula later on. It's power equals current times voltage. So P equals IE, pi. And this is a pi. You have voltage over current and resistance. You, like the last one, we didn't have current. You cover up current. You have voltage over resistance. You cover up the voltage, and you have current times resistance. And simple, that's the way to use that chart. We go into thank you for your time. If you like this and you'd like more, please follow, like, subscribe, drop your comment in the comments. There is a link in my bio to a store if you'd like to look at that. But thank you for your time. Hope to see you around.